Hi, fifth graders. Today we're going to take a look at 3 different word problems that will require you to convert customary units of measurement. And whenever you see a word problem, I always recommend reading once first just to get the gist of what's going on, and then read through line by line to get the math information you need. And that strategy is going to be especially helpful when we're converting between customary units. So let's take a look at the first example. The story problem reads, to build a new swing, Mr. Matson needs 9 feet of rope on each side of the swing and 6 more feet of rope for the monkey bar. The hardware store sells rope by the yard. How many yards of rope does Mr. Matson need? So I can very easily picture a man standing in his backyard with all the pieces for swings and monkey bars, and he's on his way to Home Depot because he needs to buy some rope. So the first sentence is going to give us 2 pieces of math information. I'm going to break that first sentence into 2 parts so we can look at it more closely. The first half reads, to build a new swing, Mr. Matson needs 9 feet of rope on each side of the swing. So I'm picturing the swing, and then I know that he needs 9 feet on both sides. That means that number 9 is going to be used 2 different times. The second half of that sentence reads, and 6 more feet of rope for the monkey bar. So now I'm picturing that monkey bar and I know that he needs another 6 feet of rope. The next sentence says the hardware store sells rope by the yard. Now there's no numbers in this sentence, but I know that the word yard is a measurement word. So I'm going to keep that in the back of my mind to see if that's going to be important as we finish our story problem. Finally, the question sentence reads, how many yards of rope does Mr. Matson need? Well, that word yards came up again, which tells me I should look closely at my units. At the beginning of the word problem, my units are all listed in feet, but at the end of the word problem, it's listed in yards. This tells me I'm going to need to make a conversion. But first, I need to know exactly how many feet of rope that Mr. Matson needs. So I'll add together 9 plus 9 plus 6, which gives me a total of 24 feet of rope. Now I can turn those 24 feet into yards so we know exactly how many yards of rope he needs. I'll list out my units from least to greatest, which for units of length start with inches, then feet, then yards, then miles. I know that I'm starting with 24 feet and I'm trying to turn them into yards. So I'll move 1 step down my list, which reminds me that since we're moving down the list, I need to divide. And because there are 3 feet in a yard, I'll divide 24 by 3, which tells me that Mr. Matson needs 8 total yards of rope. Let's take a look at another example. This story reads, Mara has a can of paint with 3 cups of purple paint in it. She also has a bucket with a capacity of 26 fluid ounces. Will the bucket hold all the paint Mara has? So I'm picturing a girl, she's got a paintbrush in her hand, she has a can of paint and a bucket, and she wants to see if she can transfer all of that paint into the bucket without it overflowing. So the first sentence gives me a piece of math information right away. It says that she has a can of paint with 3 cups of purple paint in it. So I have my can of paint, and that is worth 3 cups. The second sentence says she also has a bucket with a capacity of 26 fluid ounces. So that bucket is empty right now, but I know it can hold 26 fluid ounces. The question sentence asks, will the bucket hold all the paint Mara has? So I know I'm trying to figure out if the bucket is big enough to hold all the paint. But if you notice, the paint was described using cups, and the bucket was described using fluid ounces. That means I'm going to need to make a conversion so I can compare these two. So this is kind of like those questions where we had to compare one unit to another. You'll have to decide whether you want to change the fluid ounces or the cups. But either way, you'll still convert using that strategy. Now in this particular example, I think I'd rather convert cups into fluid ounces. So that means I'm going to start at cups and move up to fluid ounces. Since I'm moving up the list, I'm going to multiply, and I know that there are 8 fluid ounces in a cup. So I'll multiply my 3 cups times 8 fluid ounces per cup, which tells me that 3 cups is equal to 24 fluid ounces. Now I can compare that to 26 ounces. Since the bucket is 26 fluid ounces and 26 fluid ounces is greater than 24, all of the paint will fit in the bucket. So yes, Mara's bucket will hold everything she needs. Okay, let's look at one more, and you can probably guess this will be an example with weight. This story reads, Hector's school is having a model rocket contest. To be in the contest, each rocket must weigh 4 pounds or less. Without any paint, Hector's rocket weighs 62 ounces. If Hector wants to paint his rocket, what is the weight of the most paint he can use? So I'm picturing a boy standing in front of maybe a flyer that is displaying a model rocket contest coming up, and he's trying to decide if he will be able to paint the rocket that he has and still be able to enter it. So let's go line by line and look for math information more closely. The first sentence reads, Hector's school is having a model rocket contest. Well, that's great and all, but I can move on because there's no math information there. The second sentence says, to be in the contest, each rocket must weigh 4 pounds or less. So I'm picturing that flyer and it's giving me the information that it can be no more than 4 pounds. The third sentence reads, without any paint, Hector's rocket weighs 62 ounces. So I'm picturing the model rocket and I know that it has a weight of 62 ounces. Finally, if Hector wants to paint his rocket, what is the weight of the most paint he can use? So he's trying to decide what mystery amount he can use in order to still enter the contest. But there is a little part here that's tricky because the flyer talks about how the weight is measured in pounds, but Hector has measured the rocket's weight in ounces. So that tells me since I'm using 2 different units, I'll need to make a conversion. So I can figure out an equation from these pieces. So I know that 62 ounces, which is the weight of the rocket, plus a mystery amount of paint can be up to 4 pounds. So let's say I wanted to be at the very heaviest weight of 4 pounds. I could make all of those parts equal to 4 pounds and still be able to enter the contest. Now I need to convert between ounces and pounds. Just like the last example, I need to choose one of these two to convert. I'm going to change the 4 pounds into ounces. So I'll move up my list, and since I know that there are 16 ounces in a pound, I'll multiply my 4 pounds by 16 to get a total of 64 ounces. Now I can rewrite my equation that 62 ounces plus a mystery amount of paint can equal at most 64 ounces, which means that the amount of paint Hector can use can be no more than 2 ounces, because in order to fill in that mystery number, 62 plus 2 would give me 64. So those are some sample word problems you might see if you're converting units of measurement. It's very important to go line by line and look closely for all of those units so you know if you need to make a change. Thanks for watching this video.